Students, welcome back to the class. So now we'll include some of the major questions regarding the topic here. So we are going to discuss about few of the major important questions regarding the topic metals and non-metals. Okay. Here the first question is, mixed metals is widely used in the manufacture of the following. Okay, of which of the following? The first option is material of car brake, smoke detectors, cigarette lighters, emergency lights. Okay, now let us look at the answer here. The answer here is option D, option C, cigarette lighters. Okay, it is option C, cigarette lighters. So here in cigarette lighters, they will usually use this mixed metal. What is this mixed metal? It is an alloy. Okay, it is an alloy where there will be a mixture of iron alloys such as cerium, which is of 50%, lanthanum, which is of 25%, neodymium, which is of 18%, and praseodymium. Okay, all of this, it is of 5%. And along with all of these different alloys, okay, there will be few more rare metals. So all the different metals, okay, in a few quantity, based on their ratio, they are included here to make this alloy. So mixed metal is an alloy which can be used here in cigarette lighters. So due to this mixture, because when they are making this alloy, it will give a specific property which is required to light up these cigarettes. So in the cigarette lighters, there they will use this mixed metals. Okay, it is an alloy basically of iron. Moving to the next question now. Yes, here you can see. So which one of the following metals occur in nature in free state? Gold, sodium, aluminium, copper. Okay, let us look at the answer. Here the right answer is option A, gold. Okay, gold will usually, it is available in the native form itself because it is one of the stable noble metal. Okay, it already has an octet structure and it is very stable. It doesn't want it to react with any atmospheric gases or any other different metals. Okay, it will always be available in a purest form. There will be minor mixture, but still. So we will get this gold in a purest form when we are looking at this, the rest of the elements here. Because sodium, aluminium, so these are comparatively highly reactive. Okay, comparatively highly reactive metals. Whereas this copper is, it is less reactive, but it is more than that of gold. Okay, more than that of gold. So when we are looking at this reactivity series, so first here we have potassium, which is followed by sodium, calcium, aluminium, zinc, iron, lead, okay, tin, lead and hydrogen, copper, mercury, silver and gold. So here in our reactivity series, we have the gold at the least, okay, at the lowermost space, because it is least reactive when we are comparing with that of the rest of the metal. So here in the options that they have given us here, sodium is highly reactive compared to the rest of the options, followed by aluminium. Okay, so when we are looking at all of this, gold is the one which is available in the natural state because it doesn't want it to react. It will not tend to react with any of the other elements in nature, metals or non-metals. Clear? It is available in a free state in our atmosphere. Looking at the next question now. Match the items in column 1 with that of column 2. Okay, column 1 and column 2. So under this column 1 here, we have iron here. So liquid at room temperature, copper, deposition of reddish brown layer on exposure to moist air, potassium can be cut easily with a knife, mercury, formation of greenish layer on exposure to moist air. So now we are going to select few of the codes that they have given us here. Option A tells us A, we have to match it with A, 2 with C, 3 with D, and 4 with B. So option B tells us that A with B, 2 with D, 3 with C, and 4 with A. So option C here we have. So first option is with C, 2 with A, 3 with B, and 4 with D. And the last option, so first here with D, 2 with B, 3 with A, and 4 with C. Okay, now let us look at the option, right option here. So option B is the right one. Okay, let us match this here. Iron. Okay, iron is the one where there will be a deposition of reddish brown layer on exposure to moist air. So if we have this iron bars and all, when we expose it to the moist air, that is in the presence of oxygen and in water vapors, that is a moist air. So when this iron is combining with that of oxygen as well as water vapors, definitely there will be rest formation, right? Iron will get converted into iron oxide, hydrated iron oxide, which is nothing but a rust, right? So this leads to rust formation here. And when we are looking at the next option, so next, copper. Copper is the one which forms a greenish layer on exposure to moist air. So copper vessels, if you have at home, and if you leave it aside, if we are directly exposing it to the moist air, after a few days, we can see the surface of this copper with a greenish layer, right? Regularly, if we wash, so we can remove that layer. But if we are exposing this to the moist air, so after a few days, approximately for 2 to 3 days, definitely we can see greenish layer, a thin greenish coat on the surface of the copper. It's all because copper would have reacted with atmospheric moist air, water molecules, right? So this is the one which will get converted into copper hydroxide as well as copper carbonate. That is the reason, due to the formation of copper hydroxide and copper carbonate, it will form greenish layer on the surface of it. Okay, here copper is reacting with carbon dioxide, water as well as oxygen. So next option here we have is about potassium. Potassium, we know that it is one of a metal and it is very soft in nature, right? It is one of the softest natural metal available, and definitely we can cut this with using a knife itself. Since it is the softest metal, we can cut this with knife. And the last one here, when we are looking at this option, mercury, right? Mercury is the only non-metal which is liquid at room temperature, right? So we know about this. So mercury is the only mercury is the only metal which is available in the liquid form at room temperature. So this is one of the metal. When we are looking at the non-metals, bromine is the one, right? Bromine is the one which is available as liquid at room temperature. So all these are the important options that you have to make a note of this. Iron forms rust when exposed to moist air. Copper forms greenish layer when exposed to moist air. Potassium can be cut with a knife since it is very soft metal. Mercury, it is a metal and it is liquid at room temperature. Whereas rest of the metals, all the rest of the metals that we have, they always will be hard because it is solid in nature, right? Mercury is the only metal which is a liquid at room temperature. Okay, let us move to the next question now. Consider the following statements. The first statement here we have is most of the metal oxides are insoluble in water. The second statement, sodium oxide and potassium oxide are metal oxide and hence insoluble in water. So here we have these two statements. The correct answer here is Option A, only 1 is true. Option B, only 2 is true. And option C, 1 and 2 both are true. Option D, neither of the 2 is true. Okay. Okay, now let us look at the answer here. The right answer is option A. Only 1 is true. Okay, so let us look at the statement. Most of the metal oxides are insoluble in water, right? So since these metal oxides are basic in nature, the metal, when it is any of the metal that we take, for example, okay, let us take as copper. Copper is one of a metal. If it is reacting with oxygen present in the atmosphere, it is the one which is going to form cupric oxide, right? So copper will form cupric oxide when it is reacting with atmospheric oxygen. And this one, metal oxide, it is a metal oxide since it is basic in nature. So all the metal oxides are basic in nature, whereas the non-metal oxides are acidic in nature. This we have already learned in the previous sessions. So this metal oxide, which is basic in nature, most of it are insoluble in water. It is because, so a base, okay, any of the base, if it is soluble in water, okay, not every bases will get dissolved in water, but if a base, if it is dissolved in water, then that can be called as alkali metals. Okay, alkalis. We will usually call it as alkalis if it is dissolving in the water, but most of it will not dissolve. Only few of the metal oxides can dissolve. So that can be called as bases, right? So here only the first statement is true. And when we are looking at the second statement, okay, first statement is true because most of it is not soluble in water. Only few of it which are soluble in water are called as alkalis. Second statement, sodium oxide and potassium oxide are metal oxide and hence insoluble in water. Now this is a wrong statement because sodium is a metal, potassium is a metal. When it is combining with the atmospheric oxygen, it can form metal oxide. That is sodium oxide and potassium oxide respectively, right? So these two are, since it is soluble in water, okay, these two are the metals which will get dissolved in the water. Okay, these are the metallic oxide. It will get dissolved in the water. They are soluble in water. So they can be called as alkalis. Okay, so here the statement is, they have given us it is insoluble in water. No, it is not actually true. It will get dissolved in the water. Okay, because they are alkali metals. Okay, moving to the next question now. Why is tungsten used exclusively for making filaments of electrical bulbs? So tungsten has high melting point. Tungsten has very flexibility. Tungsten has low rate of evaporation at high temperature. All of the above. Okay, let us look at the answer here. The right answer is option D, all of the above. So tungsten is one of a filament, okay, one of a material which is used in making filaments. So if you are looking at this electrical bulb, so here we have a filament which is of tungsten material. Okay, tungsten material is one of a metal which is used in the making of this filaments which is used here in electrical bulbs, because it is one of the suitable material which can be used in making bulbs. So here it has very high melting point. Okay, when we are looking at the properties of this tungsten metal, so here they have very high melting point. That is, when we are providing very high temperature, only then it will get melted. If not, so the normal moderate temperature, or at the lower temperature, usually it will not melt. So this is the one which can be used here in electrical bulbs. So that is a property that we require to make an electrical bulbs, right? And it is also very flexible. So we can make a coil out of it. We can make a coil to make it as a filament. So which is the suitable property for making the filament here, right? And the next property is tungsten has low rate of evaporation at high temperature. The rate of evaporation of this metal is very low, even at very high temperature. Even though when we are providing more temperature, it will evaporate at very lower rate. So which all these properties of this tungsten material is very suitable for making electrical bulb filaments. Okay. So because of all the three properties, it can be used here in making filaments for electrical bulbs. Next question. Metalloids are alloys of alkali metals with other metals, colloids of metals, elements having some property of both metals and non-metals, metals heavier than lead. Okay, let us look at the right option here. So option C is the right answer. Okay, so here metalloids are the one which have both the properties of metals as well as non-metals. So your metalloids are the one which will usually separate the metals as well as non-metals in our modern periodic table that we have. So when we are looking at this modern periodic table, here on the left hand side, there we will have all the metals. On the right hand side, we will get all the non-metals. So in between them, in the zigzag way, there we have this metalloids. So metalloids will show us both the properties of metals and non-metals. Okay, that is what we call it as a metalloid here. And most commonly, generally popularized metalloids. Okay, the most common, generally recognized metalloids are boron. Okay, boron is one of a metalloid. It has both property of metals as well as non-metals. Silicon, germanium, arsenic, antimony, tellurium. Okay, all these are most commonly recognized. We will use this metalloids most commonly. They show both the properties, metals as well as non-metals. But less commonly recognized metalloids are carbon, aluminium, selenium, polonium, and astatine. So even all these are considered as metalloids because they show both the properties of metals as well as non-metals. Any element, if it is showing the characteristics of both metals and non-metals, that can be considered as metalloids here. Okay. Moving to the next question now. Which one is not metal? Sulfur, sugar, nitrogen, all of these. Okay, let us look at the answer now. So here the right option is option D, all of this. Okay, because when we are looking at all of this, sulfur and nitrogen, definitely these are non-metals that we know, right? Sulfur, nitrogen, oxygen, carbon. So all of these are non-metals. But this sugar, where do we classify this? Whether it is a metal or non-metal? Even sugar is also non-metal because sugar is made out of different elements like carbon, hydrogen, and oxygen. Here this carbon, hydrogen, and oxygen, all these are non-metal. So when we are combining all of this, carbon, hydrogen, and oxygen, we will get a structure of sugar. So it is considered as a non-metal. Okay. Moving to the next question now. Metals like sodium, potassium, calcium, and magnesium are extracted by electrolysis of their chlorides. So in molten state, these metals are not extracted by reduction of their oxides with carbon, because reduction with carbon is very expensive. Carbon readily makes alloys with these metals. Carbon has less affinity for oxygen. Carbon is a weaker reducing agent than these metals. So option A and B, option B, B and C, option C and D, option D and A. Okay, now let us look at the right answer here. The right answer is option C, C and D. Okay, here we have the statement C and D. So these two are the right statements according to the statement that they have given us here, right? It's all because carbon has less affinity for oxygen. Yes, carbon readily not react with oxygen. Okay, less affinity between this carbon as well as oxygen elements. These two are non-metals and the affinity between them is less because both of these carry negative charge. They are electronegative elements, right? So that is the reason for them to have this less affinity towards each other. Okay, next option D. Carbon is a weaker reducing agent than these metals. So here the metals that they have given us, sodium, potassium, calcium, and magnesium, right? All these are metals. So all these are highly reactive metal. So potassium is the strongest reactive metal. It will easily react with anything else, all the other elements. Okay, followed by sodium. Okay, which is again followed by calcium and then magnesium. So when we are looking at the reactivity series of this, so under our reactivity series, your potassium is the one which will take the first place because it is highly reactive metal. Followed by sodium, third is calcium, and fourth is magnesium. Okay, so but here we have a carbon, right? The question is, these metals are not extracted by the reduction of their oxides with carbon. So using this carbon non-metal, we cannot definitely reduce them, because if this metal, okay, let us take this calcium now, calcium, okay, if you are taking this, if it is reacting with oxygen, okay, metal plus oxygen will always form metal oxide. Okay, CaO, it is a metal oxide. So which is formed when there is a reaction between metal as well as oxygen. Metal oxide is formed. Now, the affinity between calcium as well as oxygen is high. Okay, they are combining with stronger bonds than this carbon. So carbon cannot remove the oxygen from here. Okay, using this carbon, we cannot reduce this compound. It is a compound here. Reduction is process of removal of oxygen from a compound, right? But here carbon cannot remove this oxygen from this compound, from calcium oxide. It's all because calcium is more reactive. Okay, so it is more reactive than carbon. Okay, carbon is weaker reducing agent when we are comparing it with that of sodium, potassium, calcium, and magnesium. So if we have these highly reactive metals, so when we have highly reactive metals, carbon doesn't work there because it cannot reduce. It will not become a good reducing agent since it is a weaker reducing agent. Okay, it cannot displace the other metals from a solution, from that compound. Okay, moving to the next question. So when we are looking at the rest of the option, reduction with carbon is very expensive. No, it is not actually a true statement. Carbon readily makes alloys with these metals. No, even this is not a true statement. The right options that we have here is option C and D. Okay, carbon is reducing agent, but still it is weaker reducing agent when we are comparing it with that of all of these strong reducing metals. All these are strongly, highly reactive metals. Okay, moving to the next question now. Cinnabar is an ore of mercury, copper, lead, tin. Okay, let us look at the answer now. Here the right answer is cinnabar is ore of mercury. Okay, mercury. Cinnabar is one of an ore of mercury. Okay, so when we are looking at this, cinnabar is ore of mercury, which will usually form mercury sulfide. Okay, cinnabar is nothing but it is one of an ore of mercury sulfide, where there will be high content of uranium. Okay, so the chemical formula of cinnabar is mercury sulfide. So HGS, mercury sulfide, and it is most common source of mercury. There will be high content of this mercury, and we know that mercury is a poisonous element, right? It is a metal and it is very highly poisonous. So in a cinnabar, there will be high content, more content of this mercury. And in ancient time, okay, in our very longer back, the cinnabar, since it is red metal, it is completely red in color, and due to its pigmenting color, due to its color appearance, the crystalline surface, due to this properties, it was used in making jewelries. Okay, jewelries, ornaments, but due to its toxicity, later we got to know it is made out of mercury. There is a presence of mercury and which is highly toxic. Now the use of this in ornaments, it's completely discontinued. Now no more we will use the cinnabar in making ornaments. Okay, initially it was used. So since it has a red pigment, the color of it is beautiful actually. Okay, and in our earth crust, it is generally occurs as a granular crust. Okay, in our earth crust, it will be in a form of granular, and during volcanic activities that we will get it out of the earth crust. Okay, cinnabar that is available during volcanic activities, it will take a part there. Okay, moving to the next question now. Which of the following is correctly matched? Aluminium, hematite, lead, galena, iron, bauxite, magnesium, malachite. So the right answer here is lead galena. Okay, so the correct option out of all of this option is lead. So that is galena. So here we have the ore on the right hand side. Okay, aluminium is the ore of hematite. So that is what they have given. Hematite is one of a ore. Galena is a ore. Bauxite is a ore. Malachite is also a ore. But the rightly matched, okay, correctly matched option is lead galena. Okay, hematite. So here we have hematite that we have here. Hematite is a ore of iron. Okay, we will get this iron from this hematite ore. Ore is the one which is naturally available. Okay, naturally available, which is in the solid form. Okay, so from this ore, we can extract more amount of desirable metals naturally and also profitably. Okay, ore is the one which is naturally available in the earth crust. So which will usually consist of more quantity of this metals within them. So out of this ore, we will usually extract the required metals out of it. We will get the aluminium, iron, lead, magnesium, copper, zinc. Okay, so here hematite that we have here, it is one of the ore of iron. So when we are looking at this, galena is the ore of lead. And here bauxite is one of a ore. So out of this bauxite ore, we will get this aluminium. We will generally extract this aluminium out of this bauxite ore. Similarly, malachite is also one of a ore. So from this malachite ore, we will get this copper, not this magnesium. Okay, but how do we get this magnesium? From the ore like magnesite, dolomite, carnallite. Okay, there are different ores like magnelite, okay, magnesite, dolomite, carnallite. So out of these ores, we will extract this magnesium. Okay, moving to the next question. At 30 degrees Celsius, which three metals are all liquid? So here we have Hg, Fv and Zn. Hg, Sn and Pb. Molecular formula, zinc, lead and tin. So here we have mercury, gallium and cesium. Okay, the right option here is option D. Okay, mercury, gallium and cesium, all these are the metals which are at the liquid state at 30 degrees Celsius. So it is not actually exactly the room temperature, right? Exactly at the room temperature here, mercury is the one which is naturally available as a liquid form, in a liquid form, right? Because here in mercury, all the molecules, they are joined with weaker bonds. The bonds between them is comparatively very weaker when we compare with that of the rest of the metals. So that is available in liquid form naturally in the room temperature. But when we are looking at this gallium and cesium, if we just slightly increase the temperature, that is at the degree of 30 degree Celsius temperature, it will get converted into liquid. Slightly we have to increase the temperature here so that we can convert this gallium and cesium, which was initially in solid state, will start melting down. Okay, it will get converted into liquid. So at room temperature, that is at exactly 30 degrees Celsius, when we are looking at all of these, so here mercury, gallium and cesium are the metals which are in the form of liquids. Okay, moving to the next question now. The important metal used with iron to produce stainless steel is carbon, tin, chromium, aluminium. Okay, now let us look at the right answer here. The right answer is chromium. Chromium is the right answer. Okay, out of all of this option, chromium is the one which is mixed with stainless steel. Okay, here when there is a mixture of stainless steel and chromium, chromium is the one which is used as a galvanizing layer. Okay, that is, okay, it will provide a sufficient passive film of chromium on the stainless steel, because when we are adding this chromium to the stainless steel, it will not usually allow this corrosion to happen. Okay, it will prevent the contact of oxygen and the stainless steel metal. Okay, there will be no contact between oxygen and stainless steel, so that we can prevent this corrosion completely when we are adding this chromium. Okay, it will block the surface of this stainless steel by getting the contact of oxygen towards the metal. So it will not enter the chromium inside, enter the stainless steel inside, and it will not allow it to get corroded, so that we can prevent it from corroding. So our material or the utensils that we use, which we is usually made out of stainless steel in the kitchen, right? All of it can be prevented from corrosion, so that we can use it for a longer period of time, right? So all the metals usually that we use in kitchen, stainless steel. It is all coated with chromium. There will be a layer of chromium which will not allow it to get in contact with oxygen. Okay, it will not damage the internal structure of this metal. Moving to the next question now. From which mineral is radium obtained? Limestone, hematite, pitch blende, rutile. Okay, now let us look at the answer. Here, out of all of this, the right option here is pitch blende. Okay, option C, pitch blende is the one from which radium was extracted for the first time. Okay, so it was discovered by Marie Curie as well as Pierre Curie. Okay, Marie Curie and Pierre Curie together they discovered this radium. Along with this radium, one more element that they had discovered is polonium. Okay, polonium and radium, both of these were the radioactive elements, okay, which was discovered by Marie Curie as well as Pierre Curie. And even for their discovery, they also got a Nobel Prize in the year 1903. Okay, so this is the year that they had discovered. After that, they got the Nobel Prize for the same year in the year, so 1903. Clear? So it was all discovered from this pitch blende. Pitch blende is one of a ore. Out of this material, they discovered this radium as well as polonium. Okay, radium is obtained by pitch blende here. Moving to the next question now. In which type of coal, percentage of carbon is the highest? Peat, lignite, bituminous, anthracite. Okay, let us look at the right answer here. The right answer is anthracite. Okay, here in anthracite, there will be more percentage of this carbon. Okay, it is one of a kind of coal in increasing order of metamorphosis during this complete transition from one state to the another state. Okay, so the more percentage of coal is found here in anthracite. The first one here is peat. Okay, the first one here is peat, which has a less percentage of this carbon, followed by lignite, and then subbituminous, and then finally bituminous anthracite. So here we have it in ascending order of the percentage of the carbon. Clear? Anthracite is the one which has more amount of coal within them. Clear? So along with that, anthracite coal has highest maturation stage of coal. So it has reached the highest maturation state of this coal, where there will be maximum amount of coal is present here in this anthracite. We know that coal is one of a byproduct of carbon. Coal is one of a byproduct of our petroleum, which is rich in carbon. So here in the coal, there will be presence of carbon itself, right? And it is usually shiny as well as hard. The surface of this anthracite appears shiny as well as hard. Clear? And the carbon content here, present here, is 95%. Okay, it has approximately about 90 to 95% of the carbon content, and rest of the percentage is filled with volatile material. That is the different mixture of different elements. And it also has high calorific value. So this anthracite coal is the one which has high calorific value. So what do you mean by this calorific value? Calorific value is the amount of heat that it is going to produce when we burn that completely, when the complete combustion of a taken amount of the substance undergoes complete combustion. During this process, the amount of heat it produces, that is what we call it as calorific value. And when we are looking at all of these options that they have given us here, anthracite is the one which will produce more amount of heat energy because it consists of maximum amount of carbon here. So calorific value will also be high, okay, compared to the rest of the option that we have here. No. Moving to the next question now. Which one of the following metals is used in the filaments of photoelectric cells that convert light energy into electrical energy? Tungsten, copper, rubidium, aluminium. Okay, let us look at the right answer here. Tungsten is used here in the electrical bulbs. Okay, electrical bulbs to produce electricity, right? It has to provide. So your tungsten material actually will get heated up. So we are heating it to that extent that it can emit the light. Heat energy to electrical energy to light energy that it is going to produce. Okay, that is suitable for electrical bulbs. So your tungsten filaments are made. Tungsten material is used to make the filaments in electrical bulbs. But here in our photoelectric cells, we will use this rubidium. Okay, rubidium is one of a material again, which is used as a filament in case of photoelectric cells. What is the function of this photoelectric cells now? So it is a device that can convert the light energy into electrical energy, just opposite to that of tungsten. Tungsten will convert electrical energy into light energy, right? It will emit the heat energy. That is what appears as a light. That is what we can see here as a light. But here, so in photoelectrical cells, which will convert the light energy into electrical energy. So here you can see, okay, it will absorb the light and it will emit the electricity by absorbing the light. Okay, so it is one of a device which will be used here in switches, electrical switches. There we will use this rubidium filaments, and along with that we also use in some of the power sources, light detectors, so which will usually convert the light energy into electrical energy. That is, so here you can see a photoelectric cell. This is a device. Okay, moving to the next question. Which one of the following elements corrodes rapidly? Aluminium, iron, zinc, silver. Okay, let us look at the right answer here. Yes, right option. So here the right answer is option B, iron. Okay, as we already know, iron can easily react with atmospheric air, that is in the presence of oxygen, moisture. So it will get converted into iron oxide. So finally, when it is reacted with water molecules, that is the water vapor present in the atmosphere, it will get converted into hydrated iron oxide, ferric oxide, right? It will get converted into hydrated ferric oxide, which is nothing but the rust. So when there is a formation of rust, we can say that the metal that we are using would have corroded. Okay, corrosion will start happening there. So there is, due to the formation of corrosion, we can see the formation of red, which is reddish brown in color, right? So here it is reacting with oxygen present in the air along with the water and forms this compound called iron oxide, ferric oxide. Okay, moving to the next question now. So if there is a mixture of water to this ferric oxide, so here we have ferric oxide. It is a combination of metal as well as oxygen, metal oxide, right? So this metal oxide, if it is again reacting with water molecules, it will become hydrated compound. So this is a compound. If it is reacting with water molecules present in the air, it will become hydrated compound. So which is nothing but rust here. So for the formation, for this formation of rust, here we have this molecular formula Fe2O3. So Fe2O3, which is nothing but iron oxide. So X number of water. Okay, it is going to hydrate with the water molecules. So which is a formula of rust here. Next question. Which one of the following metals is less reactive than hydrogen? Barium, copper, lead, magnesium. Moving to the next question. So the right option is copper. Okay, copper is less reactive when we are looking at all the rest of the options. Okay, so in the reactivity series, copper is placed usually below the hydrogen. Okay, so when we are looking at the reactivity series, under this reactivity series, here potassium is the one which comes first because it is highly reactive metal. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, tin. Okay, tin, after that lead, then we have this hydrogen. Okay, so above hydrogen we have all this metal, and below this hydrogen we have a metals called copper, mercury, silver, as well as gold. Okay, so below this hydrogen here we have this copper, and above hydrogen here we have barium, lead, magnesium, and all the rest of the metals. So because they are more reactive than that of copper and hydrogen. Okay, copper is least reactive than hydrogen. Moving to the next question. So here we have, okay. So here we have the reactivity series. Hydrogen is here, and below this hydrogen here we have copper. So whatever that we have, all these are least reactive metals, and that we have here are most reactive metals than hydrogen. Okay, so here we have decreasing chemical reactivity series of these metals. Moving to the next question. Which one of the following alkali metals has low melting point? Sodium, potassium, rubidium, cesium. Okay, let us look at the option here. The right answer is option D, cesium. Okay, out of all the options that we have, all these are alkali metals. Out of all of these alkali metals, the metal, okay, alkali metal with a low melting point here is cesium. Okay, compared to all, even this room temperature is sufficient to start it to melt. Okay, but still, so we know that sodium as well as potassium, they are soft in even at room temperature, soft metals. But this cesium will be even soft. Okay, even that will be a soft. But when you start slightly increasing the temperature, it will get converted into liquid, so that it will start melting down because it would have reached its melting point. Okay, so all of these alkali metals. So cesium is the one which has a low melting point. Okay, the chemical element with the symbol cesium, the symbol of the cesium is C and S. Okay, CS. and its atomic number is 55. So it is one of an alkali metal. Alkali is the one which will get dissolved in the water. Okay, the metals which will get dissolved in water, we can consider the same as alkali metal. It will form alkali solution. Okay, alkaline solution. So all of these alkaline metals that we have here in the list, all these alkaline metals are very reactive, strongly reactive, electropositive. That is, it is capable of donating the electrons to the neighboring elements. Monovalent metals, that is, they have only one valence in them, forming strong alkaline hydroxide. So when it is reacting with water, as I said you, they all of these metals that we have here will dissolve in the water when we add it to the water. So after dissolving it in the water, it will form alkaline hydroxide. For example, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Okay, they are going to form alkaline hydroxide when they are reacting with water, because they will dissolve in water since it is alkaline in nature. Clear? Moving to the next question now. Which one of the following is the softest? Sodium, aluminium, iron, copper. Okay, let us look at the right answer. So just now we were discussing that sodium is the softest metal, right? It is a metal. So all the options that we have, all of these are metals. But out of this, sodium is one of the softest metal available, right? Aluminium, iron, copper, they are usually solid in nature and they are also very hardest metals. Usually that is one of the property of a metal, right? They will usually be in a solid state and also very hardest when you touch it. But sodium, that can be cut with a knife. We can use a knife to cut the sodium. That is one of the softest metal. So along with the sodium, we have lithium, sodium and potassium. Okay, all the three, lithium, sodium and potassium, all of these are softest metal. Using a knife, we can easily cut them. Okay, but usually the general metallic properties, it has to be hard, right? Aluminium, we know about aluminium, iron, copper, that we will use in kitchen, right? They are usually hard. The utensils which is made out of all of these, they're usually hard, but sodium is one of the softest metal which is included here. Okay, lithium, sodium and potassium, softest metals that we have to remember. Moving to the next question. The first metal used by man was gold, silver, copper, iron. Okay, let us look at the right option here. The right answer is option C. Okay, your answer is right. So copper is the one which was used for the first time by man. Okay, probably copper was the one which was found naturally occurring native material. Okay, it is a native metal which is available in its original form, purest form. Okay, completely as a copper itself. So this was actually used by human beings. So initially during that age, during that stage, it was found usually in the large lumps on the ground itself. So using this copper, they completely converted into different metals later on. Okay, copper tools such as the vessels, or it can be the cutting tools. Okay, later this copper, since even though this copper is hardest metal, we know that, but still comparatively it is soft. When they started heating this copper, they will start melting very faster. That is, they have very comparatively lower melting point. Okay, their melting point is comparatively low. So that is the reason finally they mixed it with some other different metals available. Okay, this is how they learned to make an alloy. So finally copper was mixed with bronze. Initially they were using copper as a material to make different materials, different copper tools. It can be utensils or the cutting tools or any vessels. Okay, but later, since this copper, it will usually, since it has a lower melting point, the normal natural copper, it has a lower melting point. It will melt down easily, and it is even softest. Okay, not that softest, but comparatively it is softer one. It cannot be used as a cutting tools. That is the reason later human being learned that to mix bronze with copper. Okay, when they are mixing this bronze with copper, it got converted into alloy. So alloys are the one which is a mixture of 2 or 3 different metals. Okay, when we are mixing 2 or more different substances together, that will become an alloy of metals usually. Okay, finally they made a mixture of this copper and bronze together. So finally the obtained alloy here is comparatively stronger as well as harder than copper that they were using. So this is how they have learned mixing different metals to make it as an alloy. Alloy will be usually the desirable character that we will get it there for the different tools that we will use in our daily life. So however we want, we can design the instrument the same way, right? So for that we can make this alloy. So generally in the manufacture of stainless steel, that we will use it in the kitchen utensils, right? Stainless steel. So we will make it as an alloy. So here to the stainless steel, we are mixing chromium to prevent its corrosion when it is in contact with atmospheric moisture, right? So that is one of a alloy. So where we will have the desirable character in them, okay, desirable properties. Got it? So this is how slowly human being learned how to make an alloy. Moving to the next question. Stainless steel contains iron, chromium, nickel, iron, nickel, copper, iron, chromium and copper, iron, carbon and nickel, ferrous, that is iron. Okay, let us look at the right answer here. So option A is the right option, right answer. Okay, iron, chromium and nickel, as I was telling you in the previous question, right? So iron, chromium and nickel, all these three are combined together to make this stainless steel. Okay, the chemical nature of this stainless steel, where there is a mixture of 75 to 90% of it is iron. The stainless steel that we will use in the kitchen utensils, so it is all made out of 75 to 90% of it is iron itself. Okay, most natural metal. Along with that, it is alloyed. Alloy is nothing but adding more than one metals to that, only to prevent the corrosion. So here in our iron, we will add different metals to prevent it from getting corroded. So we have to prevent it from getting in contact with atmospheric moisture, that is the oxygen, so that we can prevent its corrosion, right? The rust formation. That is the reason we actually use this alloy in making stainless steel. Okay. So apart from this, okay, 75 to 90% of it will be iron. So the rest of the alloys which are added to this iron in varying amount, the different percentage usually, the ratio of it will usually differs, or chromium, nickel, as well as molybdenum. Okay, chromium is used, nickel is also used. Basically, we will also use the nickel in coating automobiles in the manufacture of this, to the iron, they will usually coat it with nickel to prevent its corrosion. Molybdenum. So all of these are alloys. Okay, we will use this alloy to make the stainless steel utensils. Moving to the next question now. German silver is used to make decorative articles, coinage metals, ornaments. The name is given because it is an alloy of copper and contains silver as one of its components. Germans were the first to use silver. It appears like silver. It is an alloy of silver. Okay, let us look at the right answer here. So option A is the right one. Sorry, option C is the right one. Okay, it appears like silver. So German silver, it is a mixture of copper, zinc, and nickel. Okay, so it is an alloy, right? Alloy material. When there is a mixture of one or more than one metal. So here we have three of it. So the same can be called as alloy, right? German silver is a mixture of copper, zinc, and nickel, which is used to make pots, toys, due to its hardness, toughness, as well as resistance to corrosion. When we are mixing this copper, zinc, and nickel together, the property finally we will get it here in German silver is usually hard. Okay, it will be usually tough. The structure will be usually tough and it will not corrode easily. It can prevent from corrosion. So that is the reason it is used to in making pots as well as toys, various decorative articles. Moving to the next question. Consider the following statements. An alloy is a mixture of two or more metals. An alloy is a mixture of metals or metals with the non-metals. Okay, which of the statements given above are correct? One only, two only. So both 1 and 2. Option D, neither 1 nor 2. Okay, let us look at the right answer here. The right answer is option A, 1 only. So look at this statement. An alloy is a mixture of two or more metals. Just I was telling about this. So it is a homogeneous mixture. Okay, so when we are using two different metals here to combine to make it as an alloy, it will get mixed in homogeneous way. So complete mixture. Okay, where one of the particle of one of the metal will get freely, completely suspended equally in the next metal. So complete homogeneous mixture we will get here in alloys. But when we are looking at the second statement here, so an alloy is a mixture of metals or metals with non-metals. No, it will always be a mixture of two or more metals, only metals. Okay, only metals when we are combining together to get a desirable property in the so formed metal compound. So that is what we know is known as alloys. Okay, moving to the next question. Which of the following copper alloys is used for the manufacture of springs and suspension filaments in electrical instruments? Bronze, aluminium bronze, German silver, phosphor bronze. Okay, let us look at the right option here. Phosphor bronze. Okay, option D is the right one. Phosphor bronze is the one which are used in the manufacture of spring and suspension filaments. Okay, which are used basically here in the electrical instruments. So there in the electrical instruments, the springs and suspension filaments are used, which are completely made out of phosphor bronze. So your prosper bonds is one of an alloy of bronze. Okay, it is so basically it consists of bronze. Bronze as a major element, major metal, along with that some of the different elements are also added here. Okay, so this alloy of this bronze is used in the manufacture of spring as well as suspension filaments, which are basically used in electrical instruments. Okay, the springs which are used there, because it has a super spring qualities, the spring qualities which is required for different electrical instrument, right? So basically springs are used in all of this purpose. And also high fatigue resistance. Okay, it will resist the fatigueness. And also excellent formability. The formation, final formation will also be completely excellent. So that is the reason this is the one which is completely suitable for making this springs as well as filaments. And also high corrosion resistant. So this bronze is the one, alloy of this bronze is the one which will not get corroded easily. So which is a suitable characteristic required for the manufacture of the springs as well as filaments. Okay, moving to the next question. Statement 1, diamond is very bright. Statement 2, diamond has very low refractive index. So both the statements are individually true, but the statement 2 is correct explanation of statement 1. Both the statements are individually true, but statement 2 is not the correct explanation of statement 1. Statement 1 is true, but statement 2 is false. Statement 1 is true, but statement 1 is false, but statement 2 is true. Okay, let us look at the right answer here. The right answer is option C. Statement 1 is true, but statement 2 is false, because diamond has very high refractive index. Okay, we know that diamond is very bright material, which is used in ornaments, jewelries. That is one of the reasons for us to use the same in ornaments manufacturing, right? Since it is very bright material. And again, the refractive index, it has to be very high. When we are talking, it is very bright. If it has to be bright, then refractive index also should be high. Okay, it can never be low. So what is this refractive index? Refractive index is a measure of bending of light when it is passing from one medium to another. So from one medium, that is from the gaseous state, if it is passing towards the solid part of this diamond, it will usually bend. Light will usually bend. So that is what is known as refractive index. Here in the case of diamond, the refractive index of this diamond is 2.417. It is comparatively higher. Okay, higher refractive index. So by this we can say that statement 1 is true and statement 2 is false. Next question. Graphite is a much better conductor of heat and electricity than diamond. This is due to the fact that each carbon atom in graphite undergoes sp2 hybridization and forms 3 sigma bonds with 3 neighboring carbon atoms. Undergoes sp3 hybridization, is tetrahedral, hedrali bonded, is free from van der Waals force. Okay, let us look at the right answer here. The right answer is option A. Okay, here graphite undergoes sp2 hybridization, and also during this hybridization, it forms 3 sigma bonds. And these bonds are then connected with 3 neighboring carbon atoms, right? As I was telling you here, carbon, it is usually connected with 3 more different, so 4 more carbon atoms. So this carbon atom that we have here, okay, if I write it here, so the 4 valency of this carbon is occupied by the carbon, and the rest of the carbon will again start occupying with the carbon again. So finally it forms a structure which is very complex structure. So here we can see. So sp2 hybridization of graphite and here sp3 hybridization of diamond. So when we are looking at this question, graphite is much more better conductivity than diamond, right? So iron will also conduct heat and electricity. Even this graphite will also conduct, but comparatively graphite will conduct more heat and electricity. It is a good conductor. It's all because it undergoes sp2 hybridization, whereas this one, that is diamond, it undergoes sp3 hybridization to form 3 more bonds. So here we can see 1, 2 and 3 bonds, 3 p orbitals, but here only 2. So one of the space is left free. So one of the electron that we have, it will remain free. That is 2pz. Okay, 2pz. That is the p shell which is there around this nucleus of this atom will be usually free. Since there is a free electron present, it will move around easily. It can move around freely throughout it, right? So while moving out, it will also conduct electricity comparatively more than that of diamond. So all the 3 bonds, there are no free electrons left here in diamond. But here we have one of the electron which is comparatively free, okay, continuously free, it keeps on rotating there. While its movement, it also carries the charges. So it is a good conductor of heat and electricity than diamond. Okay. So you have to remember that graphite undergoes sp2 hybridization, whereas diamond undergoes sp3 hybridization. Next question. In surgery, metal pins are used for joining together broken bones. These metal pins remain uncorroded in the body. What is the material of these pins? Copper, iron, aluminium, titanium. Okay, let us look at the right answer here. The right answer is option D, titanium. Okay, titanium is a material which is used to make metallic pin. And this metallic pin is the one which is used here in joining the broken bones. So here we have a broken bones. To join this broken bones, the metallic pin that the surgeons will use. Okay, these are the metallic pin and metallic clip that we have here. So why do we use this titanium pins? Why not copper or the iron here? Because of its strength. So here we have few of the property of this titanium which is suitable for making this metallic pin for surgical process. Okay, because titanium material that we use is strong. Okay, the strength of it is more. That is what we require in our body. The broken bones, it has to join properly. For that, so something which is very stronger that we have to use. Along with that, it also has low density. So one of a required desirable property. And again, corrosion resistance. Definitely it should not get corroded in our body. If the corrosion happens just like iron, what would have happened, right? So to prevent all of this, so the suitable property of a material is used in making the metallic pin that can be used for surgical process. Okay, it always, even though if it is there for longer years in our body, after surgery, the titanium pins always remains uncorroded in our body. Usually corrosion will not happen. Okay, moving to the next question. So the metal used to recover copper from an aqueous solution of copper sulfate is sodium, silver, mercury, and iron, ferrous. Okay, let us look at the right answer. The right answer is option D, iron. Okay, ferrous. So ferrous is the one which is used to recover the copper from an aqueous solution. Aqueous solution is the one. Okay, aqueous solution is the one where there will be a water, and to this water, if we add this copper, okay, if there is a copper sulfate and sulfate, If this mixture is added to the water, that becomes the aqueous solution of copper sulfate, right? So now from this solution, from this aqueous solution, if you have to extract only the copper, what do we have to do? So to extract this copper, to separate the copper from the solution, there we have to add this iron. Okay, we can add iron nail itself. So when we are adding iron nail to the same, what will actually happen? The iron that we have added, which is in the form of solid, it will start reacting with copper sulfate solution, which is in the aqueous solution. Okay, aqueous state. Aqueous is nothing but where the compounds are in a mixture which are dissolved in the water. Okay, so you're the elements which are added to the water. So when we are adding water to that, that becomes aqueous solution. So iron copper sulfate solution will combine and react together. So after the reaction, so final reactants, the products that we will get out of this is iron sulfate, that is ferrous sulfate, which will remain in this aqueous solution. That means, so the ferrous will get dissolved in the water, it will remain in the solution. Finally, we will get this copper. Copper can be separated out of this. Okay, to separate this copper, we have to add iron. So that finally it becomes iron sulfate, ferrous sulfate, copper can be separated, which we can remove it out of the solution. We can separate this. Okay. So because iron is more reactive than copper, okay, when we are looking at all of this here, iron is more reactive than copper. So it can be used to recover the copper from copper sulfate solution. So got it? Iron is more reactive, which will remove the copper from the solution and it will occupy, okay, displacement reaction that we can observe here. It will displace the place of this copper. It will combine with sulfate to form ferrous sulfate. Next question. Consider the following about non-metals. Non-metals are malleable. Non-metals are ductile. Non-metals are brittle. The correct answer is 1 and 2 are correct. 1 and 3 are correct. 2 and 3 are correct. Only 3 is correct. Okay, let us look at the right answer. The right answer is option A. 1 and 2 are correct. So these two are the statements which are true. Okay, because non-metals, when we are talking about the non-metals here, they are actually non-malleable. Okay, they are not a malleable. Non-metals are, okay, so these two are the wrong statement. Okay, so only 3 is correct here. So these two are wrong statements. So this is the right statement that we have. Okay, so metals are malleable, metals are ductile, but these non-metals are not malleable. They are brittle in nature. Non-metals are not ductile. They are non-ductile non-metals. So malleability is nothing but if we start beating this non-metals. Let us take this carbon as an example. Carbon is a non-metal. Let us take this as an example. And if we start beating this carbon piece, what will actually happen? Using a hammer, if I start beating it, so it will then further broken down into smaller pieces, right? We cannot convert this into a thin sheet, just like in the case of iron or the gold or the silver, right? If I take a piece of iron, if I start beating it by applying more and more pressure, definitely I can convert it into thin sheets. So we have aluminum foil, gold foil, silver foil, right? So that is the nature of malleability. That is nothing but malleability, where the metals can be converted into thin sheet. What do you mean by this ductility? So if I take this small piece of carbon again, and if I try to draw it into thin wires, okay, if I try to draw it into thin wires, definitely I cannot do that because it will break down again into pieces, right? Because it is non-metal. So that is one of the property of this non-metals. Whereas if I use this metals, for example, gold or iron, copper wires we will use in electrical cables, right? Because of its ductility, high ductility. Okay, but non-metals cannot be, okay, they are completely non-malleable, non-ductile, but they are brittle in nature. Brittle, which is nothing but if I hit it with a hammer, it will break down into pieces. but metals will not break it down. Okay, they are malleable. They will get converted into thin sheets, as well as we can also draw it into wires. Okay. So here the right option is non-metals are brittle in nature. Moving to the next question. Which of the following statement about magnetite ore of iron are correct? So it is known as black ore. It contains 60 to 70% of pure iron. It possesses magnetic properties. Select the correct answer given the using the code given below. So 1 only, 2 and 3 only, 1 and 3 only, 1, 2 and 3. Okay, let us look at the answer. The right answer is option D. Okay, so here all the statements are correct. First, second, as well as third. All three statements are true according to the magnetite ore that we use. Okay, it is one of a ore of iron, right? So this magnetite is also known as black ore because it appears blackish in nature. So here you can see this is a magnetite. Okay, magnetite ore. From this we will usually extract this iron. Okay, it is the ore naturally available in the earth crust. This is how we will get. From this we will take in all the iron components. Okay, iron metal. So they appear blackish in color, right? So it is also known as black ore, and it usually consists of 60 to 70% of pure iron. Okay, so in this magnetite there will be about 60 to 70% of pure iron. Magnetite, that is Fe3O4. This is a molecular formula which is one of a ore which possesses magnetic property, right? So when we are looking at these statements, it is also known as black ore, and it consists of 60 to 70% of pure iron. It possesses magnetic property. Iron, we know that it will get easily attracted with that of magnet because it has some magnetic properties. Okay, so all these statements are true according to the magnetite here. Moving to the next question. Until the 19th century, aluminium was almost as expensive as gold. The invention of inexpensive way to extract this metal by a 22-year-old American made this metal inexpensive subsequently. The inventor was Goldsmith, Mont, Charles Martin Hall, Parks. Okay, let us look at the answer. The right answer is option C, Charles Martin Hall. Okay, so he was the one who discovered to extract this aluminium in inexpensive way. So how can we easily, without expensing more, without spending more of it, so how can we extract this aluminium from the ore easily? So that is what is found out by Charles Martin Hall, and he was, so during this discovery, okay, during this invention, he was about only 22 years old, and he is basically from America. Okay, Charles Martin Hall, so was American inventor, businessman, as well as chemist. So he is best known for his invention in the year 1886 of an inexpensive method of producing aluminium, which became the first metal to attain widespread use since the prehistoric discovery of iron. Okay, later, so during those days, so it was equally expensive as that of gold. So extracting this gold from the ore is again difficult, right? It is not easy. So even aluminium was also equally costlier. Okay, it was equally expensive. Later, this American scientist finally found out the way of extracting this aluminium easily without expensing much. Okay, so later on, nowadays we know that today we will use the aluminium for most of the materials that we use in our daily life, right? We are using this aluminium easily, and it can be easily extracted. Okay, moving to the next question and the last question of this topic. The alkali metals have relatively low melting point, Which one of the following alkali metal is expected to have the highest melting point? Lithium, sodium, potassium, rubidium. Okay, let us look at the answer. So here the right answer is option A, lithium. Okay, lithium is the one which has high melting point when we are comparing it with that of the rest of the alkali metals that we have here. Okay, alkali metals are nothing but the metals which will get dissolved in the water, okay, to form alkaline solution. So that is what we call it as alkali metals, as we have discussed already. So usually these alkali metals, they are very stronger, right? So they have a high melting point. But when we are looking at all of the options here, lithium is the one comparatively they have more highest melting point. So it is approximately about 180. Okay, the melting point of lithium is 180.5 degrees Celsius. Okay, this is the melting point of lithium. But when we are looking at the rest of it, that is sodium, the melting point of this is 97.79 degrees Celsius. And potassium, it is about 63.5 degrees Celsius. And rubidium, that is 39.3 degrees Celsius. But when we are comparing it, all of this with the lithium, lithium is the one which has highest melting point, right? So it is, all these are alkali metals. So out of all of these alkaline materials, alkaline metals, usually this lithium is the one which has the highest melting point. That is, we have to provide more temperature, highest temperature if we have to melt this lithium, right? But sodium, potassium, rubidium, only with this temperature, it will usually start melting down. It will attain their melting point. Okay, melting point is the one where the solid, from the solid to liquid, if you have to convert that, so the point at which it will convert into solid state to liquid state, that point we call it as melting point. And for lithium, it is 180.5 degrees Celsius, highest one. Got it? Okay. So students, today in this class, you have learned about some of the most important questions which are related to the topic metals as well as non-metals, right? So we have discussed about most important questions of metals and non-metals in this class. Thank you for attending the class.